Let's talk about adding and subtracting radicals. Now remember back in the day when we added and subtracted variables? Watch this just for a second. If I had 3x plus 4x, you would say, yes, those are like terms, and that would be 7x. You add x's to x's, you get x's. Well, radicals are the same thing. You only add and subtract like radicals. 6 radical 2 plus 5 radical 2. Are they like radicals? Yes, they're both radical 2's, so I will get something radical 2. 6 plus 5, and that will be 11 radical 2. Yes, it is that easy. Is that what you were thinking? What's your answer on this one? 7 radical 3 plus radical 3. Did you say 8 radical 3? Don't forget, just like if I had 7x plus x, there's a 1 in front of that x. You would get 8x, remember? In radicals, this is just like a 1 in front of this radical 3, so 7 radical 3 plus 1 radical 3 is 8 radical 3. Let's try this one. 6 radical 5x plus 2 radical 5x. Are those like radicals? They are. They're both radical 5x, so you will get a radical 5x. 6 plus 2, that will be 8 radical 5x. 5 radical 24 plus 4 radical 54. Those, my dear friends, are not like radicals. This is when I want you actually being very familiar with perfect radicals so you won't have to draw the factor tree all down here. Nothing is wrong with a factor tree, but the more you deal with radicals, you should start recognizing like the best way to break a radical down. These are not like radicals. You cannot add them. But let's see if we can simplify each one. Let's concentrate on this radical 24. I'm going to break that down to radical 4 times 6. I have just gotten used to when I see 24, 4 times 6 is the fastest way to my answer. Radical 4 is perfect of 2. So it comes out as a 2. I can multiply the 2 times the 5 now. I will get 10 radical 6. Now let's look at 4 radical 54. I will have 4, and I'm going to break 54 down into radical 9 times 6. 9 is a perfect number. When it comes out from underneath the radical, it is a 3. 3 times 4, that would be 12 radical 6. Now, I have broken down both of these as far as I can go. Maybe I'm done, but maybe I'm not. Do you see what we have? After a little bit of simplifying, I did end up with like radicals, so I can add them. 10 radical 6 plus 12 radical 6, that will be 22 radical 6. Oh, look at this one. I'm going to have to work a little bit for this one. 5 radical 18k minus radical 72k. Those are not like radicals. Radical 18k. I'm going to bring my 5 down. I'm going to break 18 into 9 times 2. Of course, I can't forget the little k. Radical 9 is perfect of 3. So when it comes out from underneath the radical, it is a 3. This 3 times 5 will be 15 radical 2k. Okay, we have to work with 72. Let me go over here. I'm going to use a little scratch paper. Radical 72. I'll worry about the k in a second. But 72, we have a few choices. You could have used 9 times 8. 9 comes out, that would be 3 radical 8. 8 can go even further. That will be 4 times 2. And 4 is perfect of 2. I will get 6 radical 2. Or maybe some of you have gotten used to the way I do it. When I have a large number, I'll take it and I'll divide it by 2. I'll divide it by 3. I will divide it by a smaller number to see if I get a nice, big, perfect radical to make my job a little easier. When I take 72 and divide it by 2, I get 36. I am smiling about that because I instantly know 36 is perfect. And so I have decided that I am going to break 72 down into 36 times 2. Don't forget your K. 36 is perfect. And when it comes out, it is perfect of 6. So I will bring that 6 down. That'd be radical 2K. I have everything simplified. 15 radical 2K minus 6 radical 2K. Sorry, that's a little bit slanted. But you know, I majored in math, not in art. Okay, so hopefully you can still read that. 15 radical 2K minus 6 radical 2K is going to be something radical 2K. It will be 9 radical 2K. And that is my answer. Not quite as hard as it looked. Now do not look at that 9 and think you're going to change it to 3. It's not underneath the radical. You're done with that. It's just 9. A lot of people, they see 9 and they just want to keep breaking it down. 9 is not underneath the radical. The answer is 9 radical 2K. Now what about adding and subtracting radicals if you see a cube root? Well, we don't change the rules. Remember, we said you can only add and subtract like radicals, just like with variables. You can add an x to an x, you get an x. You can add a y to a y, you get a y. Well, you can add a cube root of 7 to a cube root of 7, and you get a cube root of 7. You just add the coefficients. 4 plus 5, that will be 9 cube roots of 7. And 7 does not have any perfect cubes in it, so I'm done. Let's try one more problem on adding and subtracting radicals. Okay, we have the cube root of 16 plus 7 cube root of 54. Can I add these? Are they like radicals? No, they are not like radicals. So what we do, we see if we can simplify each one first. With the cube root of 16, please don't say 4. Remember, it's a cube root, not the square root. Have to be careful there. Well, does 16 have any perfect cubes in there? Well, if I take 16 divided by 2, okay, 2 times 8 is a factor, and 8 is one of my perfect cubes. I will break this down to 8 times 2, and the cubed root of 8 is 2. 2 would come out. So I would have 2 cube roots of 2. Plus, now let's work on 54. Once again, when I think of 54, a lot of times I will think 9 times 6. And that's great if it's a square root, but once again, this is a cube root. Yes, I could use my factor tree, get a little scratch paper and figure this out. But if I divide this by 2 or 3, sometimes I will find the other number is a perfect cube or square or whatever I'm looking for. Well, the cube root of 54, I can break that down into 2 times 27. 27, I know, is one of my perfect cubes. That little index card I suggested that you make in an earlier video really helps you become familiar with what numbers you're looking for. The cube root of 27 is perfect of 3, so a 3 comes out. 3 times 7, that would be 21, and I would have the cube root of 2. Now maybe I'm done, and maybe I'm not. I have 2 cube roots of 2 plus 21 cube roots of 2. That will be 23 cube roots of 2.